Good morning, STEM 3. Today you're going to be working with the VEX Cortex and learning how to operate the motors. So we're going to start with downloading and making a copy of the Clawbot tank drive project so you have some guide code to start with. So to do that, you're going to open featured projects. You're going to use the little scroll bar wherever it went. My scroll bar is missing. Where'd it go? Oh, we'll just drag it over then. And we are looking for the Clawbot tank drive project. So you're going to open that up. And once you have it open, you're going to go over here to options and you are going to copy the project. When you copy it, make sure you put your name in the copy of the project, and then you're going to click OK, and that will make a copy of the project that will look like this. That will be on your starting home page. So once you make a copy of it, now you can start editing it and adding and changing things and not having to save it. Make sure again that you're logged in, otherwise it will not save your copy and you will lose any changes that you make. So I'm just going to walk you through this program and kind of explain what the different parts of the program are doing, and that way as you edit and modify things, you know what you're editing and modifying. So the very first thing up here, this import VEX, what that does is it imports the VEX library. So this is a Python program, and somebody's gone out there and written a whole library of methods or commands that work with the VEX components. And so you have to import that library, otherwise Python doesn't really know what you're asking it to do when you use some of the commands coming up. So this first section here is configurations. And so what they've done is they've made a variety of variables, right, claw, arm, left, and joystick. And they are then assigning those variables to different VEX components. So notice we're using dot notation. So we have to first refer to the library. We're saying we're going to go back to the VEX library, or technically, for those of you who have done programming before, this is asking for the object that's been built from the VEX library, the VEX object. And we're saying we're going to make the right variable a motor that's plugged into port 1. And by saying true, that's basically saying adding this other parameter that's saying run it. While this thing says true, we're going to be able to run this motor. The claw is in motor port 6, the arm is in motor port 7, and the left motor for the tracks is in port 10. Now, something you need to know about these ports 1 and 10 have built-in motor controllers. Any of the other motor ports do not. So the motor controller, I put a copy of the document into the motor's assignment so you could read about it. But the motor controller basically allows the joystick or the brain to read how much power is in the motor and control that. So especially if you are going to try to program it with any kind of autonomous movement where you want to set it at 50%, or you want to set it at 95, or you want to count how many rotations it's making, things like that, you need to use a motor controller. Otherwise, the motors are like all on or all off when they're in any port other than 1 and 10, which is why I gave you enough motor controllers for each of your motors. So if you would like to change which port a motor is in, or you want to add another motor for something besides, say, like a claw or arm. For example, if you're making legs or jaws or something like that, you can rename these variables so that they make sense to you, and then you can change which port that particular motor is assigned to. Now, the joystick basically says anywhere where there's joystick, we're going out and we're making that use the joystick methods from the VEX class as well, the VEX library. And so all of those things are the configurations. Basically, what we just said is each of these different variables are going to represent these different parts. So now in the rest of the program, we can refer to the variable name. We don't have to keep setting up all those configurations. So when we scroll down here to this joystick deadband thing, I've actually never used that in a program before. So I'm not sure exactly why you would do that, other than it gives you a true off. When you have a dead band around 0, that would mean that if the joystick gets close enough to 0, but maybe not exactly 0, that it considers it off. And that way, if there's little nuances in your joysticks and there's slight bleed, electrical bleed through there, that your motors don't just run all of the time. All right, in this next section, we're in something called a while loop. And again, those of you who've done programming are familiar with this term. Basically, as long as the while loop is true, this code is going to run. If somehow that while loop becomes false, it would stop running. So the way that you can get a never-ending loop where this program will run at all times is by putting it into a while loop and setting that while loop to be true. And if we scroll down here a little bit, notice that as long as it's true, the left will run on joystick axis 3 and the right will run on joystick axis 2. Now let's say, for instance, you've decided I would rather switch that around. I'm using my joystick the other direction. Or instead of left and right, I'd rather run, legs and jaws. You can again, edit the configuration to the variable names that you want, or you can change these axes here so that they represent what you want them to be. So the joystick has buttons, the joystick has 2 axes, and if you want to look at where you can see those configurations, if you look off to the right hand side here, notice we have button 5 up, button 5 down, button 6 up, button 6 down, button 7, button 8, axes 1, 2, 3, 4. These are all parts of the joystick that you can actually use to control your motors. So one of the first activities that we're going to do is you're going to map out the joystick by changing each of these axes numbers and seeing exactly which parts of the joystick run which, respond to which of these labels. So in the next section, this is the claw section. And so if the button 5 up is pressed, it's going to run the claw motor at 50%. If the button is down, it's going to run it in the opposite direction at 50%. Else, it's going to be off. So it's going to stay in the off configuration of the motor until either the button's pushed up or down. Now, the variable here is a percentage. So obviously the highest number you could put in there is 100 or negative 100, and then 0 would technically be off. But notice we also have the off command when we use claw.off. And then there's also the arm motor that's also connected to button 6, and again the same kind of configuration is being used here, where we have the button up, the button down, else the button is off. Some other little just kind of tidbits about Python that might be different from some of the previous programming that you've done. Notice that we don't have a ton of brackets like we do in Java and JavaScript. Python is completely based on indentation. So notice the highest command, while true, is all the way to the left. And then the commands that are within that while loop are uh, tabbed in one tab. So that's where you get your left, right runs, your if, your else if, and your else. And then notice the if, else if, and else have other commands below them. And to indicate what's within that command, there's another tab in. So Java is set up and organized by tabbing rather than the use of brackets. You'll also know that unlike Java, we don't see semicolons after all of the commands. When you call a function, so for example, left.run and right.run, these are function calls or method calls. There's no colons or anything afterwards. But when you look at the if and the else ifs and the else, notice there's not a semicolon, a colon after each of those. So the colons are setting up those conditional statements, and then the calls are after that. So just a little bit different syntax than maybe what some of you are used to. So as I said, your first activity is going to include kind of manipulating some of these numbers and seeing how they work. So you're going to be putting motors in different ports and renaming these numbers to show that you can identify which port they're in and edit where the motors are. And then you're also going to gradually change this axis 3, axis 2, button 5, those kinds of things, and figure out what each of these different commands, which part of the joystick those are referring to. So there you go. If you have any questions, you know where to find me, and hopefully you have fun getting to know the basics of your VEX motors in your STEM kit.